So around half of you have done something with server-side Swift, and for the other half, you're kind of interested but haven't built anything yet. So for half of you, I think the first question might be an interesting one, which is why server-side Swift? So really, there's three reasons that server-side Swift is interesting. The first is mobile backends, right? You're writing a mobile application. And most mobile applications now are not standalone. They're not completely self-contained on the device. So you need to start using some kind of back-end capability. And there's three ways you can do that. The first is just to use those directly. So you connect to the Google Maps APIs or the weather company for weather resources and so on. The second is to use a dedicated MBAS, so a mobile backend as a service, something like Firebase or Realm. And then your third option is to actually build bespoke backends, which is what you tend to do if you have your own capabilities that you need to connect to, or you start to want to write backend logic. Now, on that right-hand side, one of those options is to use Swift, which obviously we think is the right thing for everyone to be doing because you get to use exactly the same programming language that you have on the device, on the server. You actually get to share code, particularly your data models. And with the announcements this week around Swift Package Manager support inside Xcode, it's now going to become much easier to take model definitions that you have on the server or on the client and share them between the two by taking those models, wrapping them as a Swift Package Manager project, and then importing them into both the iOS and the server components. So mobile backends is a really big case. The second one is microservices. So this is cloud-based services that provide function and don't have to be tied to the use of an iOS device on the front end. So this is generic programming. And Swift is actually a really good fit in those scenarios. One, because of fast startup. And fast startup, particularly in clouds, is interesting because, first of all, clouds are designed to dynamically scale according to load. Right? So if you have a server and it becomes overloaded because of the number of requests that you have, a cloud is more than capable of just provisioning a second server dynamically. But the speed at which it can provision that and bring that up and have it handle requests is all to do with startup time. So the faster applications start and shut down, the faster they can react to load. And because Swift is completely compiled, it starts up something like 100 times faster than something like Java. The second is low memory. Right? Because Swift is designed to work on a device, it's inherently designed to use a small amount of memory. And it actually uses about 1/8 of the amount of memory that Java does, about 1/4 of what Node.js does. So it's very small footprint. And again, in a cloud deployment, that's important because clouds charge you according to the amount of memory that you use. So if you use half the amount of memory, you pay half amount to run that server. And finally, it's the interop. Right? It is that ability to share models between the two. And with the power of things like Codable and the JSON encoders in the Swift language, you can guarantee that your data structure is going to get converted to JSON, sent over the wire, and then converted back into the object in a consistent manner. So those are two, right? Build backends, build microservices. And the third is because it's fun. Right? You already know Swift, and you get to write Swift in more places and do more things with it. You don't have to go and learn a new programming language to write backend or do server development. So that's kind of the why. So how far have we got? Well, the server-side ecosystem for Swift kind of started at the end of 2015. Right? And the first event that really started the roadmap for server-side Swift was actually Perfect. Perfect announced they were going to be available in November 2015. And actually, it was in December 2015 that Swift was released as open source. And that was the first point that it was available in Linux. So Perfect actually started with the idea that you're going to write server-side Swift applications on a Mac. Right? The idea of Linux was not actually there at the time. So December 2015, Swift is open sourced. And at that point, we had a build that could be done on Linux. There was no official release of Swift on Linux, right? It was Swift 2.1. It was available on a Mac only. If you wanted it on Linux, you built it yourself, or you took a header stream driver from swift.org. Now, the effect of it being open sourced was in January, Vapor was released. 0.1, so everything that went out was a 0 point, but within 6 weeks, 2 months of Swift being open sourced, we had a second framework that arrived. A month after that, Kitura was released as well. So this was really rapid innovation. We'd literally just released the ability to build Swift on Linux, and we already had 3 frameworks arrive within 3 months of that happening. Then in March, Perfect went 1.0. So they got to the point that they thought they had a stable, GA-able implementation within 4 months of the language being available. And this was even before there was an official build of Swift on Linux. But this was because Perfect was looking at Mac as a target environment for this. Then what happened was September that year. We'd spent 9 months trying to do things like get dispatch running on Linux so we could get it into Swift 3 so that it was actually possible to have concurrency, which on a server, when you want to deal with hundreds of connections, is vital. So Swift 3 in September 2016 was actually the first release where you could use Swift officially on Linux. And we literally got dispatch in about 5 weeks before it was released. But Swift 3 being released and us now having official builds on Linux meant that Perfect 2 could come out supporting Linux. Vapor 1 was released, and Kitura 1 was released all that month. So really, day 0 for server-side Swift was September 2016, right? Which, when you think about it, is only 2.5 years ago. So shortly after that, we set up the Server Swift Workgroup. And one of the reasons for doing that was, in order for each of those 3 frameworks to build and get to where they had, each one of them had to build their own networking stack. Right? We'd all gone out and actually built a server networking layer. We'd built our own crypto libraries. We built a whole load of infrastructure independently. And if you work with any server-side language, so you work with Node.js, you work with Java, you work with Ruby, all of that's built into the language itself. So we kind of grouped together and said, rather than us independently building networking layers, we should work together and build a common networking layer for the good of the Swift community. So the Swift Server Workgroup set out to do just that. Vapor, May the next year, released it 2.0. Swift 4 came out then that September, and Swift 4 was when Codable arrived. And that was a huge, huge difference, right? Anyone that's ever had to work with JSON parsers in Swift absolutely hated it. So Codable made a huge difference because REST APIs are mostly all about parsing and dealing with JSON. So the release of Swift 4 led to Perfect 3 coming out and Kitura 2. And Kitura 2 was designed to make as much use as Codable as possible. So it was really a real change in its APIs to be Codable based. Then, February the next year, Swift-NIO arrives. And that kind of is that solidification of what the Swift Server Workgroup laid out to do. It became the standard networking library for server-side Swift, which the frameworks can then start to leverage, and new frameworks don't have to build their own networking layer anymore. And this has actually led to Amazon with the Smoke framework, Point Free Co. These guys built directly on top of NIO because they now have a reusable networking layer available to them. That was exploited directly by Vapor 3 immediately. So in the same way that Kitura 2 leveraged Codable the moment it was available, Vapor 3 leveraged NIO the moment it was available. And then since then, we've had Swift 5, and we've had Swift-NIO 2 coming out at the start of this year. So that's the kind of roadmap that we've been through. And really, even inside this, which is only a couple of years, there's been 3 phases. The first one was really about rapid innovation. Right, so this is inside the first 9 months of Swift being open source with no official builds on Linux. We got Swift working on Linux. We released it as an official GA. 3 frameworks built networking layers and infrastructure and built full frameworks within 9 months. then each of those frameworks, particularly because of Swift 4, did their next major version. And this was when they started to do Swiftification, right? Those first frameworks, because Swift itself was really new, there was no codable and so on, those frameworks were each modeled on an existing framework from somewhere else. Kitura was modeled on Express.js from Node.js and on Sinatra from Ruby. Vapor at the time was modeled on Laravel, and Perfect was modeled on, oh, it'll come to me. But each of them was modeled on a set of APIs that existed from another language. This was the point that those frameworks then did a new set of APIs which is designed to be Swifty. And then finally, we're now entering a phase which is all around standardization, where we've removed those independent networking layers and we've replaced them with Swift-NIO. And we're also looking at other libraries that need to be standardized and supported across the Swift ecosystem. So that brings us to the current status, right? Where are we actually today? So the first thing is there's actually 11,000 Swift Package Manager packages on GitHub today which export some kind of module. So they export a library. They're not just someone's Swift Package Manager project, right? So these are all reusable libraries available for Swift Package Manager. And you've got to remember that up to the start of this week, Swift Package Manager was really only used for projects on Linux and on the server. So this is kind of like what our server ecosystem is today, or I actually grabbed the numbers yesterday, so it's yesterday. So that's where we are, 11,000 packages. But how does that actually compare? Is that a lot? Does it cover everything that we need? Well, let's call them the market leader, right? The market leader for having packages available to the development community is NPM. Node Package Manager has 830,000 packages at the moment, right? And I will point out that's like 3 times more than any other language ecosystem. So they are way beyond everybody else. So when you compare Swift and Node, you can say that we don't actually have a particularly mature package ecosystem. And actually, if you look at the graph of it, this is what it looks like. So there's a huge gulf difference between the two. But what you've got to remember is, if you look on the far left-hand corner, where that scale starts, right? NPM actually arrived for Node in 2010. Node arrived over a year before that. So Node Package Manager arrived about a year into Node.js existing. So let's take a look at what happens if we actually time shift based on 0 time being when NPM arrived for Node.js and when Swift 3 was released, our first release on Linux, which was actually also the first official release with Swift Package Manager support. So if we do the time shift, this is what it looks like. So we are a little bit behind, right? Based on that time scale, NPM got around 15,000 packages. We're on about 11,000. So we're a little bit behind Node, but then Node is by far way beyond any other language ecosystem. So this pretty much says that we are on track to have a huge ecosystem. And not only that, this is all being done when Swift Package Manager wasn't being used by anyone on iOS. It wasn't being used by people building macOS apps either. It was really just being used by the server ecosystem. And with the change earlier this week that it's now built properly into Xcode, we're expecting that's going to start changing, right? And people are actually going to build SPM first. So is that 11,000 packages enough? Well, this is some of what you've got, right? We've got JWT, JSON Web Tokens. There's support for MariaDB, SendGrid from Twilio, Redis, CouchDB, Kafka, Stripe for payments. There's a lot more than that. There's also Hadoop, Cassandra, Postgres, MongoDB. Pretty much anything that you regularly would want to do, there's actually already a package for it. Now, this is good in terms of coverage, but one of the problems that the Node community has is having 830,000 packages is a good thing, right? Anything that you want to do in Node, there's a package for it. Their biggest problem is that they have 830,000 packages. So there isn't one package to do anything you want to do. There's probably 50 or 100 of them. And then you've got to work out which of those is actually one that's going to be maintained and carried forward, Which of those actually has a good architecture under it, and which of those can you actually use and rely on long term? So what the Node community actually had to do to fix this, and they started this about 6 months ago, is they set up a community work group, and that community work group is called package maintenance. So they've started to look at which are the key packages that lots of Node.js users rely on, and start to take the community and say, we now need to help those packages get to the point that they provide long-term support, that there are people available to fix security vulnerabilities in them. So they're now trying to go back and curate those 830,000 packages to make it possible for people to really rely on them. What we've been doing kind of goes the other way. Right? We set up the Swift Server Workgroup, and that's designed to standardize a set of capabilities that we know that everyone needs to be able to rely on. So the Swift Server Workgroup process itself looks quite a lot like Swift Evolution, but it sits separately to Swift Evolution. So there's the ability for anyone to do a pitch, convert it into a proposal. That then leads to a real project, which, based on the status of that project, could be in sandbox or it could be in incubating. There is a set of rules that you have to follow in order to get to the point that you are graduated. But this means we're actually building a curated set of foundational modules from the get-go. Right? We're doing it from the beginning. We're not going to wait until there's 20,000 different packages that do the same thing and then try to choose which one we're going to help. We're making sure it's done right from the bottom up. Now, as well as that pitch process, we've been working on a few other things. One of those that was crucial was Docker support. So anyone that's building an application now and deploying it to be hosted to a cloud is pretty much doing it in Docker. There was a community project that was creating Swift Docker images. But there's a couple of problems with that. First of them is, how do we make sure we have Docker images available for nightly builds and daily builds and branches as soon as they're available from Swift.org? And the second is, Docker has the sense of official images. And official images can be automatically rebuilt on Docker Hub by Docker itself the moment there's a change to an underlying layer. So if you're using a Docker image on Ubuntu, and Ubuntu releases a new version with a security fix, all of the official images that build on top of Ubuntu get automatically rebuilt. So by having official Docker images for Swift, you get security patches in the operating system immediately for free. So we took what the community was doing, we brought it in, we've now started to update it to add multiple different releases, have nightly builds available, and so on. The next thing we wanted to do was logging. Actually have a consistent logging API that everyone uses, so that when you bring in new modules, and those modules have a logger, it uses the same logger that your framework uses, that the other module uses. So you have consistent logging across everything that's in your application. The same thing for metrics. Right? If you're running an application, you need to see its logs, and you need to see how it's performing. And again, if you want to get metrics from every component, you need a consistent metrics API. And then you need to be able to work with persistence. So Postgres was the first one we worked on. Redis is also being added. So we're starting to basically build a whole load of core components as a cross-vendor group, you could think of it as, right? Because Vapor's involved, IBM's involved for Kitura, Apple themselves are involved. And what this means is we've now got to this point where we have a consistent standardized networking layer in Swift-NIO. We have consistent logging and metrics available that sits next to it. We have some consistent libraries for doing database and persistence. And we have the ability to then wrap that in an official Docker image for deployment to a cloud. So kind of all of that foundation is now done as a group, as a community in a standardized way. Now, we then have our frameworks. And frameworks is really where all of the innovation should happen. Right? There are multiple different ways to solve the problem as to how to build an API. And there are different APIs that developers use to build those REST APIs. So frameworks and having multiple frameworks is always a good thing because it actually feeds innovation and ongoing development of different approaches to solve problems. So we have those three major frameworks, Kitura, Vapor, and Perfect. I mean, as I said, adding in Swift-NIO made it possible for other people to start building frameworks as well. So you've got the Smoke framework from Amazon. This is where Amazon, inside their video encoding team, started to use stuff internally, and they've released that to open source. And you've got Point3Co, who've released their Swift server layer, which uses purely functional programming to do server development. So if we look at some of those frameworks, and we'll look at and that's not stopping. There are more things we want to bring in. Distributed tracing is on the list. Cryptography, so a standard set of libraries for crypto, is on the list as well. So if we look at 3 of those frameworks, Vapor, Kitura, and Perfect. So I think probably one of the most asked questions is, which one should I use, and how do they compare? So I think the first thing to say is all of them have got performance and scalability. Right? They all perform well. There's always benchmarks you can look at which will compare and say one is faster than the other. But generally, that comes down to that specific benchmark. Right? Each of those framework owners can write a benchmark which their framework will be fastest at. It's pretty easy to do that. You just start off by actually looking at what the other frameworks are slow at and attack that. But they are all performant, and they are all scalable. For Kitura, we run 10,000 concurrent users against one server as a test. And we know it survives that and doesn't really affect in performance. You can use each of them to build REST APIs and web applications with templating and server-side rendering of your web views. All of them have authentication, and they have security. All of them have persistence and data storage. And all of them have cloud integration. And in fact, Vapor now they had Vapor Cloud. They're now releasing a new version of that called Vapor Red, which allows you to run Vapor applications backed by providers like Heroku or DigitalOcean. Kitura's approach is to bake in cloud standards. So as part of your project, you get support for Cloud Foundry build packs, which are used by Cloud Foundry technology and Heroku. We provide built-in support for Docker and Kubernetes, which almost every major cloud provides. So we built that in as part of the application itself. And Perfect is Perfect Assistant, which has capabilities in there to make it easy for you to deploy to things like Amazon. So they all have all of the basics that you need. So how do you actually decide? Well, there is no good answer to that. A guy called Brian Schick at Ray Wenderlich has written an article that certainly compares Vapor and Kitura. And the summary of that pretty much comes down to the best framework for you is the one that you feel most comfortable with the programming model for. And just to show you how they kind of compare from his article, this is a REST handler from Vapor. So you write a get-all handler to handle GET requests. You receive a request. You're going to respond with a future. And in this case, it's going to return an array of users. So you return a future promise that you will actually create that array of users. And this is doing a user.query, so it's fetching data from a database, and it's going to return all of the users that it finds. If you wanted to add authentication, you would go into the request. You would say, I require authentication of a user type object, and that object self-describes how to go and get the right headers out of the request and deals with creating a user. It uses a try, so if there's a problem, it's going to throw, and the framework will handle the throw and send an error back for you. He also covers how you do templating and actually build a web view. So here, you can take an incoming user parameter, and you can use that to build a view. Now, because the view is different to the user parameter, this requires you to use FlatMap to kind of do a transform of a future. And what that's going to do is going to get all of the acronyms for a user. That then gives us a list of acronyms. We then need to convert that to a view, which again means doing another FlatMap. And that then creates the user context in the view that you're going to return. This is the kind of approach for REST APIs that you see in Kitura. Kitura doesn't use futures and promises. It deliberately uses completion handlers because we're trying to follow the model that's commonly used in iOS, where most async work is done with completion handlers. The other difference you'll notice is in that REST API from Vapor. If you wanted to have user authentication, you wrote a line of code to do it. In Kitura, we embed that in your parameters. So this basically says, I want a user auth object. So Kitura looks at the request and tries to inflate the data to a user object. If it can't do that, it rejects the request for you. It does query parameters on a URL. So what this does is it says, where you put question mark name equals John, it looks at that, has to be able to convert it into a journal entry params object. If it doesn't, it rejects the request as being invalid. And once it's done that, it gives you a completion handler, which you can use. And journal entry makes a database call, so you then can say, find all entries matching my entry parameters query for the user that we authenticated for you, and we give it the completion handler, which it will then execute when it completes. So really, it's just different programming styles. Vapor uses futures and promises, and Kitura uses completion handlers. So it becomes your choice as to which style of programming you'll become more familiar with. So what else is going on? Well, accelerated Linux releases. So anybody here that tried server-side Swift in the early days on Linux will know Foundation was far from complete. And one of the problems was we could fix stuff in Foundation. But you still had to wait 3, 4, maybe 6 months for an official build to come out with those fixes in. Now, the state of Foundation is significantly better than it was 18 months ago. But we've now got accelerated Linux releases, which means if we need to get fixes out just on Linux, Swift.org will now release a Linux-only build, which means we can get those fixes out faster, and you don't need to wait until there's going to be a Mac build as well. More platforms. So if you've been following some of the community work, there are now viable builds on Windows available. There are builds on ARM. There are builds on Red Hat as well as Ubuntu. Some of those are more official than others, but all of this has been happening in the last year. And I think another of the more interesting ones is the language server protocol. So this means that so the language server protocol effectively allows an IDE to do code completion and syntax highlighting. So the side effect of that is that language server protocol means that you can now program Swift in VS Code. And remember, VS Code is not a Mac IDE. It's multi-platform and multi-language. So you can now do development of Swift applications on VS Code on Linux. There's also now Swift Studio. So Marcin has released his own macOS IDE called Swift Studio that uses the LSP to give you exactly the same kind of experience you get in Xcode. But some of the stuff that he's done is he's built Docker support directly into the IDE. So if you're building an application and you want to see what it's going to look like running in Docker on Linux, you press the Run in Docker button, same as you get the Run button in Xcode, but it's going to build and run it in a Docker container for you. So that's, I think, going to be a huge difference to certainly exposing it to a wider set of developers than just people who build iOS apps in Xcode today. So cloud deployments. Pretty much any app that you want to deploy really does need to go into a cloud so it's accessible. As I said, what we did with Kitura certainly is we built support for Docker to package, Helm, which lets you deploy to Kubernetes and Kubernetes itself, Prometheus for metrics and Grafana to visualize it, and Open API support, so Swagger, if you've heard of it, is built in directly. You've also got the ability to then deploy to any cloud. Vapor, as I said, has its own cloud with Vapor Red. We know of people who are deploying Server Swift applications into Microsoft Azure, into Heroku, into DigitalOcean, into Google Cloud Platform, IBM Cloud, and so on. So pretty much any cloud that you need to be able to deploy an application to, you can. So that kind of really brings us to the last topic. Is anyone really using it? Right, we've said you can. We've said the ecosystem is there. But is anybody actually building server-side Swift applications? Well, Capital One are. And this is an interesting one. They actually only talked about this for the first time about a month ago at Swift Cloud Workshop 5, which was held in Washington, D.C., actually hosted by Capital One. And the usage that they talked about was something they created called imitation. So this is a record and playback server for API requests and responses. So during their own development, in order to be able to work against back-end APIs, which serve banking requests, they record requests against those APIs and their responses, and then they can take that recording and they can run it directly in iOS and in the iOS simulators. So they now have the ability to basically get mocked responses from a back-end API. And they've done this based on a Kitura server, and they've lifted it, and they actually drop it into iOS. So iOS can test and run its own backends directly internally and play back responses for their testing and development. There's also the Meter app. So Erwin is just in front of us, one of our volunteers here. And he's built an iOS app with a Kitura backend that's designed to help people meet people at conferences who know about things that you would like to learn about. And you also share your own skills profile so people can find you to come and talk to you. So it's kind of like an expert matching system. Now, that's it's on test flight now. So if you come and find Erwin, he'll sign you up for it if you want to try it out. So those are two examples, but you might argue that they're not really at scale. So is anyone really using it at scale? So has anybody used online Swift Playground.run? Now, this is kind of like what you get from Playgrounds, but hosted on a server so that you can run any code you like directly in the browser. So all of that is backed by Kitura. It's running directly in a cloud, running on Kubernetes, and it will handle as many requests as anyone makes of it. It hasn't actually had any downtime or scale problems that we are aware of. There's also agenda.com. So agenda.com is a notes application for macOS. And what it does is it organizes your notes into a timeline, and it synchronizes those across devices using iCloud. It actually won last year's design award here last year at WWDC. Now, the back end for it, for data, is iCloud, but they have a license server. And that license server that it uses to check to see whether or not you have a valid license is running on Kitura based in a cloud. So that's a couple of cases, but there's a couple other which really are starting to run at bigger scale. So there's Allegro, which is built entirely on Vapor running in Kubernetes. And Allegro is a Poland-based e-commerce company. And they rewrote their entire infrastructure using Swift on the server with Vapor. And they have been amazed at the reduction in cost and the performance that they've got out of it. Now, the presentation here was done at Swift Cloud Workshop in September last year. The video is online. I would recommend anyone going and watching it just to get an independent person's overview of what it was like to take Swift and run it in scale. And this isn't for an iOS backend. This is them writing real microservices. And another one which is truly at scale is Ask Mercedes. And they actually talked a little bit about this here at AltConf last year. So their Ask Mercedes app.
Ask Mercedes is an augmented reality app that allows us to virtually assist you and answer any questions regarding your new vehicle. Simply tap the Explore My Features button. The app is now in scan mode. Align the image of the interior with your vehicle. This step is needed to calibrate the AR features.
So all of that is running with a Swift backend based on Kitura. And originally, they rolled it out just to E-Class Mercedes in North America. They've now rolled it out to a wider set of classes and worldwide. And when you consider that they sell around about 2.3 million cars a year, and everyone gets this as their app, you can imagine the scale that it now needs to run to at the back end. So the final one, right, but is anyone actually willing to put money on it? Right, we've seen some of it's running at scale. But you could argue that, if the Mercedes backend goes down and I can't use my online manual, if agenda.com's license server goes down and I have to retry a minute later, well, what about doing banking? So Fin is a subsidiary of ING, who is one of the largest European banks based in the Netherlands. And they have created an offering that they call Banking of Things. So Banking of Things basically says, I'm going to delegate the ability to make payments on my behalf to devices. One of their first examples of this was kind of simple. It was in the Netherlands. There is a requirement that all new houses now have air conditioning. Not necessarily to cool the air, but actually to do air filtering, so it's clean air. So the first thing they did was they allowed the air filtering units to make payments. So the air filtering unit looks at the degradation level of the filters themselves, and at the point that it needs to be replaced, it buys a new filter, which gets delivered, and then you just replace the filter. So it's starting to make payments. And they've now got a number of different cases where this is being used. Potentially one of the more interesting one long-term is when you start to think about self-driving cars. Right? If cars can self-drive, and they can take themselves to the charge point, and they can make the payment for the charging themselves, then all of this is done on your behalf. So they're building a system where devices are going to be able to make banking transactions. So if we look at the infrastructure for that, they have a core API server. That itself has a layer of persistence, so it's a REST API with some persistence. Now, they have then a number of IoT SDKs which can be used on various devices. And those talk securely to the server using JSON Web Tokens, which are then encrypted and authenticated. They have a set of web APIs. This is all currently running Node.js, which allows people to have a web view of their accounts. They can look at transaction payments. They have the documentation, and so on. They have iOS and Android apps. The iOS app, of course, is written in Swift. And then they have a payment processor, which actually does the financial transactions against financial services. So if we look at the breakdown of that, the API server is 100% Swift running Kitura. The SDK for programming on devices is available in Swift. The iOS app, of course, is in Swift. The payment processor, the thing that's actually doing those financial transactions, that's written in Swift running Kitura. And then they have their backend APIs, which are their existing infrastructure. They're also making use of cloud-based monitoring because all of this is being run in Kubernetes in a cloud. One of the things, and this is quite interesting, is their REST server is currently running at 0.4% CPU. So they do not have any scaling problems whatsoever. And their production monitoring for RAM says they pretty much run at 25 megs of RAM usage, which you start a Java application and it needs 86, let alone before you start to put any load through it. So there are people not just using Swift on the server, not just using it at scale. There's banks actually doing transactions with it. So if I wanted to get started with Swift on the server, where do I go? There are a lot of resources. There are courses with Udemy and Udacity and Lynda and LinkedIn Learning. Hacking with Swift, so Paul Hudson, he has an area for server-side Swift. He's got a couple of books, one for Vapor, one for Kitura. RayWenderlich.com. So RayWenderlich.com has invested heavily in bringing server-side Swift education over the last 12 months, I would say. They have a new server-side Swift pillar to find out and have articles and video courses around server-side Swift. The two people that run that pillar are in the room with us today. We have Tim Condon and we have Dave Oken. You can put your hands up so that people can pester you later. And they've also got books for Kitura and Vapor. And one of the unique things here is the Kitura book was written by myself and David. The Vapor book was written by Tim and the Vapor team. So Ray gets the actual people that work on the technology to write it, which means the stuff that we know about that we may not have done such a good job of documenting anywhere are in those books. And finally, Tim, you're going to have to put your hand up again. There's the Server-Side Swift conference. So first round was last year. It's running again in November in Copenhagen. So we've actually now got our own Server-Side Swift conference. So we've got to the point where, and to me it's almost frankly amazing, right? We've gone from having the first release of Swift on Linux, literally in September 2016. Less than 3 years later, we have 11,000 packages. We have Fortune 100 companies who are in production using Swift on the server. We've got an ecosystem that's building around it. Some of the problems, things like Swift Package Manager support being server-side Swift only, that's gone. Apple themselves are investing heavily. You've seen Swift-NIO, you've seen Package Manager support, you've seen the announcement of the Combine framework as well, which is heading down those lines. It's actually amazing when you think of where we are now and you compare it to things like Node, which is 10 years old, or Kotlin, which is 8 years old, or Ruby, which is actually approaching 30. Right? What we've achieved in like 2.5 years with server-side Swift is kind of phenomenal. And with people starting to use it and starting to actually share what they're doing, it kind of just builds the momentum. So thank you for attending. There's going to be the ability to ask us questions outside afterwards. I'll be there, Tim will be there, David will be there. So if you want to know more, you want to just have a discussion, come and find us afterwards. Thank you.